define local maximum and local minimum. Suppose f is defined on X, takes value in R, this is given. We see that f has a local maximum at a point P in X if there exists a neighborhood with radius delta so that f of P is the largest value. It's f of Q less than equal to f of P. For every Q in the neighborhood of P with radius delta. Local minimum is similarly defined. That's f of Q is larger than equal to f of P. A local minimum is similarly defined. So a local maximum may not be a global maximum, right? Global maximum is within the domain is the largest value, right? Local minimum is just in a small neighborhood is the largest value, right? So a local maximum is kind of like the mountains, right? The top of the mountains, right? Locally is the highest point, but then global maximum is like the highest point in the world, right? The largest value. All right, we look at the theorem. Let f be defined on the closed interval AB. If f has a local maximum at a point x in AB, and if f prime of x exists, then the derivative of f at x equals 0. So at the maximum point, the derivative must be 0. Algebraically, this is straightforward. For t near x, for example, that's a t for any t in this neighborhood of p of x, right? So then we know that f of t minus f of x over t minus x. If t is less than x, the numerator is always f of t is smaller than f of x, right? It's smaller than or equal to. So the numerator is non-positive. The denominator here, t is smaller, is non-positive. So the quotient is non-negative, right? And if t is larger than x, well, this is still non-positive. This is positive, right? So the quotient is negative, non-positive, right? It's like this, right? So f prime and x equals the limit as t approaches x from the left. That is, t is less than x. That's in this situation. And this difference quotient is always non-negative, right? So it's likely equal to 0. And we can let t approaches x from the right as well. And in this case, we use this inequality, right? We see because t is larger than x now, right? So this is less than equal to 0, right? So this derivative is larger than equal to 0, and it is less than equal to 0. It must be 0, right? That's a proof. Right? Well, there's, I think it's called a law theorem. Now let me just prove the general situation, then we're done.